We've been led to believe that carbon dating can be used for 20,000, 30,000 BC or something, and we get these pictures of sort of prehistoric people. The thing about carbon-14 is it cannot be calibrated beyond 3000 BC for the simple reason you can't test it against any kind of historical records. And even actually within the last centuries or last few thousand years, you have a lot of wrong readings. In fact, over 50% of them get rejected. It makes you wonder why the less than half of them even get accepted in the first place. Dr. Libby was the person who discovered carbon dating, and he actually said himself, "The first shock Dr. Arnold and I had was that our advisors informed us that history extended only back 5,000 years. We'd initially thought that we would be able to get samples along the curve back to 30,000 years, put the points in, and then our work would be finished. We learned rather abruptly that these numbers, these ancient ages, are not known. In fact, it is about the time of the first dynasty in Egypt that the last or the earliest historical date of any real certainty has been established." So we're looking at the last 5,000 years.
We're going to look at some of the problems and limitations of radiocarbon dating. The first of these was an assumption made by Willard Libby when he first developed the technique. The assumption was that the ratio of carbon-14 to carbon-12 in the atmosphere had remained constant over time. Raw radiocarbon dates are reported in years BP, standing for before present. Present is set at 1950 AD. That's around the time that Libby developed the technique, but it's also before there had been so much testing of atomic weapons that the levels of carbon-14 to carbon-12 in the atmosphere were completely changed beyond recognition. So a date of 1900 BP, 1900 years before 1950, would be about AD 50. But as ever, it turns out it's not that simple. The amount of carbon-14 being created in the Earth's upper atmosphere has actually varied over time. It's thought due to factors such as sunspot activity. Human activity has also affected the ratio of carbon-14 to carbon-12 in the atmosphere because of all the burning of fossil fuels that we've been doing since about the 17th century. And this makes it really difficult to use radiocarbon to date more recent archaeological finds. We know that the levels of radiocarbon in the atmosphere have not remained the same over time because we're able to check them using other techniques such as dendrochronology, tree ring dating. The tree ring sequences can be matched up to go back many thousands of years, and by looking at the ratio of carbon-14 to carbon-12 within the rings relating to each year, we're able to see how they fluctuated over time. We can go back even further using speleotherms, mineral deposits that build up over time in caves. But we don't stop there. We constantly check the accuracy and the precision of archaeological dating techniques by comparing them against each other and, where possible, against historical dates. It's a huge, ongoing operation, constantly being retweaked. Libby may have invented the technique, but as ever with archaeology and with science, it's the work of hundreds and thousands of people doing their everyday job carefully, checking their results, that makes progress possible. All of this information gets fed into programs which help archaeologists to turn their BP dates into real date ranges that they can use. There is an element of statistical probability to all of this. We have to choose how certain we want to be. So we take a normal distribution that assumes the dates in the middle are the most likely and compare it against the wiggly line that represents changing amounts of carbon-14 over time. That gives us a date range rather than a specific date. We can choose to have a really wide date range with a 95% probability that the date falls within it. Or we can be more precise in our date range, but go for only a 68% probability that the true date falls within it. Another limitation of radiocarbon dating is that it can only date back so far. If you think about the way the technique works, it involves progressive loss of carbon-14. And since what we're measuring is the ratio of carbon-14 to carbon-12, eventually the amount of carbon-14 left is just too tiny for us to measure. The limit varies depending on the amount of sample you have and the type of equipment you use, but it's typically between about 50,000 and 80,000 years BP. We can compare this with another technique sometimes used by archaeologists, potassium-argon dating. Potassium-40 has a half-life of 1.3 billion years, And we measure the accumulation rather than the loss with this technique. So this technique actually becomes more accurate the older it is. Since we can't change the half-life of radiocarbon, the only way we can increase the dating range is by improving the equipment, allowing us to detect ever tinier amounts of carbon-14. These days we can measure much smaller and much older samples thanks to accelerator mass spectrometry. This technique accelerates the carbon isotopes, a bit like runners going around a racetrack. When they reach the detector, they're counted. The heavier ones move more slowly, so they reach the detector later. Another limitation of radiocarbon dating is that it only allows us to date organic materials, bones from animals or humans, or their teeth. Bones aren't only found in burials, they could have been used to make objects such as this comb. Other organic materials might be preserved in special conditions. Wood, as charcoal, can still be dated. Animal products such as leather are relatively rare finds, but they are sometimes preserved, for example in waterlogged conditions. In archaeology, context is everything. We may find a piece of inorganic material, such as a pot, in the same context as the organic material we're able to date, and so we can date the inorganic material by association. And we don't rest there. We check it against all our other forms of dating, such as typology, to make our interpretations as robust as possible. That's important for more reason than one, because radiocarbon dating is not cheap. Archaeologists have a really specific name for the final limitation or problem with carbon-14 dating. It's called the old wood problem. It's best explained through examples. Imagine that you cut down a tree and use the wood from that tree to build a house. The wood at the middle of the tree is going to be older than that at the outside. In addition, wood can stick around in the structure of a house for centuries, or wood from an old structure could be repurposed. We see this all around us today, and it's no less true in the archaeological record. Here's another thing that we might be quite familiar with today: antiques. This comb made of bone would be dated to the time the animal died, but it could have been passed on for generations before it finally entered the archaeological record. This human habit of hanging on to things is called curation. This is another reason that we don't look at objects in isolation. We look at assemblages in their archaeological context. In the end, it always comes back to context.